A Venn diagram, it's one of the most intuitive ways to visualize sets. Let's say we have a set A. We draw a circle and label it A. All the elements of A are inside that circle. So let's say A is the set of the numbers 1, 2, and 3. In the Venn diagram, we can represent this by the elements 1, 2, and 3. Now suppose we have another set, which we'll call B, and A and B have no elements in common, so we draw two separate circles. So now we have set B, which has the elements 10, 11, and 55. As you can see, A and B have no elements in common, no intersection, so they are disjoint, which means we draw them separately. Now if we have a set C, which does have an intersection with A, we draw the circles overlapping. The overlapping region, which is this one, represents the intersection A intersection C. What about A union C? Well, everything inside at least one of the circles represents the union. So this would all be A union C. We can also represent the universal set. So let's say again we have set A, set B, and set C. We usually represent the universal set, which is everything under consideration, as a rectangle around the circles. I'll call this U. Now let's say we want to represent B minus A. B minus A is everything that is B and is not A, which can be represented by this area. Now how can we represent the complement of the set C? Well, usually we write the complement as the set with a little c here, or sometimes like this, or sometimes like this. These all mean everything in the universal set that is not in C. In the Venn diagram, we can say that everything in the universal set, which is not C, is the complement of C. So in short, each circle is a set, overlaps show intersections, the whole area covered shows unions, and shaded regions can show differences in complements. Venn diagrams help us a lot when you're trying to reason visually about set operations.